All right, so problem number 1 says the angle of elevation from the bottom of the world's longest slide located in Peru is approximately 10.3 degrees. The slide has a vertical drop, and if we have a vertical drop going down, we remember just like a vertical line, I'm trying to draw on my paper, it is going to be this right here, so the vertical drop is 821. If we have an angle of elevation of 10.3, the relationship between that angle of elevation and the vertical drop is opposite, and we're trying to find the length of the slide, which will be our hypotenuse, which is x. If your group wants points, you need to turn your paper in now. I've said that 3 times. No. Well, turn in what you got. If you have 10.3, it's going to be the sine of 10.3 equals 821 over x. However you want to solve, you know you're going to take the 821 and divide by the sine of 10.3, which should give you approximately 4,590 feet. Well, this is what the textbook says because there are 3 significant digits here, so they rounded to 3 significant digits. You all got what? 4,591. Okay. 0.7. Okay. Now, number 2. Any questions on number 1? Number 2 says a child holds the end of a kite string 36 inches off the ground. So this is one of the ones like we did in class the other day where you had to add in the height of the fire truck. We're already 36 inches off the ground. Then we have it doesn't matter how tall the child is. We have a angle of elevation of 68 degrees. We know that the line from the child to the kite is 540 inches, so our relationship again is going to use sine opposite over hypotenuse. In this case, our variable's in the numerator, so we're going to multiply both sides by 540. Once we get that value, we're going to add in the 36, and we get 537 inches. Does anybody have a question about number 2? Number 3 is significantly different because it does not give us the length of all of the sides. Number 3 tells us that a jet took off at a rate of 260 feet per second and climbed in a straight path for 2.3 minutes. 3.2. What was the angle of elevation if its final altitude was 12,000 feet? So we are straight up 12,000 feet. We are trying to find the angle of elevation, and we know that this path, you've got 2 numbers going on. It tells us our speed is 260 feet per second, but it tells us we've been going for 3.2 minutes. So I converted my minutes into seconds by saying 3.2 times 60. That's how many seconds I've gone. And then I multiplied by the 260 feet per second, which gave me a hypotenuse of 49,920. From then, I just used my sine of opposite over hypotenuse, and I got an angle measurement of 13.91 degrees. If you are solving for an angle, you must use the inverse, the sine to the negative 1. Anytime you're solving for an angle, you are going to use either sine to the negative 1, cosine to the negative 1, or tangent to the negative 1. Number 4 is significantly different. It is harder. I will be the first to admit it is harder, and that is why I'm recording it, because I haven't had time yet to make it through. I probably won't finish this in these 2 minutes, but I am recording it. I will finish the recording and post it onto Edmodo, post the link to Edmodo. There are two things we don't know. We don't know this distance from on our second triangle, and we don't know the height of the tower. So we are actually going to have two variables. We have two different triangles. One triangle, one right triangle, is going to be the right triangle that has an angle of elevation of 31 degrees. So this is going to be 31. This right triangle has a height of y down here at our tower, but its base, we don't know the base. We are going to have to represent it as 47 plus x. We know we have a right angle, but we're going to have to represent it as 47 plus x. The second right triangle that we have, if y'all will give me just 1 minute so I can get you this far, it is going to have a base of x, y, and 52. So if you set yourself up, which one of our trig functions are we using? Opposite and adjacent. This is the tangent of 52 equals y over x, and this is going to be the tangent of 31 equals y over 47 plus x. No, it's a two-variable equation, just like a system of equations. You're going to have to solve for y and plug in, and then solve for x. I will post it, probably a bonus question. Your bonus question will be like this. Hey everybody, I'm sorry that I didn't get this finished in class, but you can watch the end of it. So, here we have our two right triangles. The green triangle, we know the relationship between 31 degrees and y is opposite over adjacent, so that is where the tangent takes place. Tangent of 31 is equal to y over 47 plus x, and tangent of 52 is equal to y over x. Now, just like any other two-variable system, we have to either use graphing, combination elimination, or substitution. But because we have two variables and the tangent involved, we really can't graph this, nor can we use combination elimination, because if we add them together, nothing's going to cancel out. So we're going to use substitution. I am going to solve for y because I can easily substitute in y. And it's up to you. You can solve for x and plug in for x. I decided to solve for y so that I could plug that in to my numerator over here. And so if I solve for y, I can easily multiply both sides by x so that I get y equal to x tangent of 52. Or you can write it as the tangent of 52 times x. We are then going to take this relationship, our y is equal to the same thing in the problem, so we can plug this in. That is going to leave me with the tangent of 31 degrees equals the tangent of 52 degrees times x all over 47 plus x. Now, this is where we're getting into our algebra skills. We cannot have a x in the denominator, and so we are going to have to multiply both sides by 47 plus x. So we are going to get the tangent of 31 times 47 plus x equals the tangent of 52 x. We then have to distribute so that we have the tangent, or 47 tangent of 31 plus the tangent of 31x equals the tangent of 52x. We can get the x's on the same side by subtracting the tangent of 31x minus the tangent of 31x. So now I have the 47 tangent of 31 equal to the tangent of 52x minus the tangent of 31x. I've got to get x by itself, so it's kind of like the reverse distributive property. If you remember, the reverse distributive property is to factor, and so we are going to factor out an x so that we have x times the tangent of 52 minus the tangent of 31, and divide both sides by the tangent of 52 minus the tangent of 31. If you want to see that step, we've got 47 tangent of 31 equals x times the tangent of 52 minus the tangent of 31. Excuse me. And then we're going to divide both sides by that. So the tangent of 52 minus the tangent of 31 are going to cancel out. And the tangent of 52 minus the tangent of 31. And then from there, we just put this in our calculator. You need to be extremely careful with putting this in your calculator because you need to make sure that with each parentheses around the tangents that you close those out. And you should get x equal to 41.5. However, that's not my answer. I want the answer for y. And so if we come back, let's find another color. We'll go with purple. If we take this 41.5 and we plug it in here, it doesn't matter which one you plug into. I'm going to be lazy and plug it in here. That x equals 41.5. Obviously, we can see that we're going to multiply both sides by 41.5. So y is going to equal 41.5 times the tangent of 52. And I'm going to work that out. 41.5 times the tangent of 52 is going to be approximately 53 feet. This is a rockstar question. I am not going to try to sugarcoat that, but it is definitely doable, and all of you are capable of understanding how to use a system of equations to solve this angle of elevation problem. Have a great night.